Welcome to this video lecture on effect of variable dielectric medium in a capacitor, a case study. We'll consider a parallel plate capacitor. We are all aware that a parallel plate capacitor has a dielectric medium between the two plates, and they are going to be separated by a distance d. Right? Suppose if the same parallel plate capacitor has got two dielectric medium of different relative permittivity, what is the effect? And if the distance of separation also varies, or the thickness of the dielectric medium varies, what is the effect? So we'll just see the effect. So we'll consider a parallel plate capacitor having two dielectric medium with a relative permittivity of epsilon R1 and epsilon R2. We'll consider the first case. If these two dielectric mediums takes up the same distance, d, what is the value of capacitor? If these two dielectric mediums take variable thickness, what is going to be the effect? So first case, we'll just assume that first medium epsilon R1 is going to have a thickness d, and epsilon R2 also is going to have thickness d. And if you take up the parallel plate capacitor, the potential across the capacitor V is going to be equal to sum of the voltage across the individual dielectric mediums. So it is V1 plus V2. So what is V1 over here? V1 is going to be electric field, right, into the thickness. Here both the mediums are going to be different mediums. So the electric field in both the mediums are going to be different. So V1 is going to be equal to E1 into D. V2 is equal to E2 into D. And when you calculate E1, it is going to be charge density divided by epsilon naught into epsilon R1 for first one. And for second one, it is charge density divided by epsilon like naught into epsilon R2. And when you calculate the value of V, automatically, right, it is going to be summation of these two values. And when you calculate the value of capacitance C1 for this case, it is going to be the numerator part is going to be A into epsilon naught. And if you take up the denominator part, it is going to be the ratios of thickness to the relative permittivity. So ratio of thickness to relative permittivity, it is a factor which decides the value of capacitance. We'll consider the second case, right? Suppose if the second dielectric medium is going to be of thickness D1, and the first dielectric medium is going to be 3 times D1, what is the effect, right? So again, in this case also, the capacitance when you calculate, right, it is going to be A into epsilon naught divided by the ratios, right? So the first medium, right, it is going to be 3 times D1 divided by epsilon R1. And for the second medium, it is going to be D1 divided by epsilon R2. And the value of relative permittivity of two mediums is going to be different in this case also. This will greatly influence the value of capacitance. And if you take up the ratio, right, ratio of capacitance, so it is going to be a higher one, right? The capacitance, it is going to be C1 is going to be 3 times C2 because the ratios are going to be higher value here. We'll just see how this thickness affects the dielectric strength of the capacitor, right? We know each medium has got its own dielectric strength, and the dielectric strength will vary based on the applied voltage, the nature of medium also. So we'll consider the second medium to be of air and the first medium of medium to be glass, right? So we all know based on the property of glass like glass can offer higher dielectric strength. So we'll just see. Like so, if you take up the second dielectric medium, which is going to be of air, uh, right? When you add these two dielectric field value, and when you take up the distance to be d1, uh, then if you take up d1 to be 1 centimeter and v to be 2050 kV per centimeter, the second one can offer 100 kV per centimeter, and the first one can offer 1950 kV per centimeter. So glass offers a higher dielectric strength compared to the like voltage. Thank you.